Can you see my presentation?
Yes.
Awesome. All right, so the topic for today is data management. I prepared a few slides for today, but you will see that many of the slides are just my view in some aspect of data management or why data management is important. And I also have some slides for recommendations. But I will be happy to do this presentation more as a conversation, so just feel free to mute yourself and talk, interrupt, ask any question, disagree with me. I think that will be important. All right, so, oops. All right. All right, so the plan for today is that I will talk a significant amount of time about the importance of managing data. And then I will go to recommend some actions to do effective data management. So I guess that the first thing is that to define what is data. I really like this definition from the Oxford Dictionary because it says that it's facts or information, especially when examined and used to find out things or to make decisions. And I like this definition because it's kind of holistic in the same data includes methods and protocols used to collect information itself, and the software and procedures used to analyze it. The next question is, well, why managing data is important? And I think that we all can agree that that is an essential aspect of more modern business models. Just as a mental exercise, just imagine that you go to your bank or to your superannuation company one day and you say, well, I'm here to claim, my funds. And the person in the other side of the counter say, oh, I'm sorry, we have lost your data. Your data was more than 10 years old. The person who was managing your data left the company 2 months ago, and we really don't know where the data is. I think that you will be right to be upset and angry. And of course, I just mentioned this silly example as a way that, well, how many times this happened to us in the other side of science? How many times we can, keep data and for how long? All right, so I think that we also can agree that science centrally depends on data. Again, remember when I say data, I am talking about information, data itself, but protocol, software, and code. But something that is important to notice as well is that science and academia, while they are related, they are not the same. I'm mentioning this because academia incentivizes some metrics like papers, funding, patents, novel ideas, but doesn't necessarily incentivize good data management. Like people don't get promoted because they practice good data management. They get promoted because they get funding, they get papers, right? So for me, this creates a conflict, and the conflict is that while data is paramount to science, data management is not in the priority list of academics. Well, data management is important because it aims to unlock the data and make it easy to capture, organize, analyze, visualize, and generate knowledge. Some of the reasons to practice good data management is because it can save time and money to yourself and to your team and to others. It can make data reusable. Of course, if you are into open science, you can also share data, make an impact by sharing the data. And of course, there are other moral and ethical reasons. If you are trying to seek the greater good for the collective knowledge, I think that preserving data and making it reusable is also important. Not to mention that some funding bodies require that you preserve the data into the future. So I prepared this kind of survey that I did to 10 of my friends, and they were physicists, chemists, biologists in their majority. But maybe I can do it here by a show of hands, virtual hands. how many of us have received training in data management? Maybe people who have received training in data management can show their hands in Zoom, and I will just quickly count. I will assume that people who doesn't show their hands, okay, cool. Yeah, so we have like 2 so far, 3, cool. All right, so 3 out of, I don't know how many here, but in my small survey, when I asked my friends, again, there was totally a biased survey, just my friends from different disciplines. I surveyed 10 people, oops. And this was their answer. 6 of them didn't receive, they haven't received training in data management, and 4 of them had received. And I think that proportion is quite similar for our little group. There's a message in the chat. Oh, I cannot see it, sorry.
Legana is saying that there was no training, just 1 hour of workshop that was not useful at all.
Okay, yeah. So I guess that the other question is, well, how many of us has organized data management training for fellow junior colleagues and lab mates? I'm not talking about doing something like this, that is awesome. And we should thank Chloe for starting this movement. But I am talking more about, sitting with your friends or lab mate in the lab and going through, okay, what is the data that you are generating? How are you going to curate the data? And so on. So I did the same survey with my friends, 10 of them, and there was the answer. So just 1 person from this small survey has actually trained other people to do data management. So what we can see for this is just, I want to, like show that effectively data management is not in our priority list. And of course, I'm not saying that we are bad people, it's just because the system doesn't incentivize good data management practice. So given that we are in a coding group, I thought I will paraphrase this phrase from Martin Fowler, who is a developer. He says that any fool can write code that a computer can understand, but good programmers write code that humans can understand. So allow myself to paraphrase this. What I say is any scientist can collect data for a scientific publication. Good scientists collect and make available data for the human collective. And of course, what I'm trying to say is that, well, collecting data is not about producing a publication, but it's about, curating the data into the future. So something that had been important to me to improve my data management practice is to understand the life cycle of data. And of course, I will mainly focus on data related to science. So in science, the classical approach is we have the scientific method where you go and you do an observation, then you formulate a hypothesis, you do an experiment in the lab or in the field, you collect some data that it becomes evidence that can be neutral against or in favor of your hypothesis, and based on that you predict knowledge. The problem, well, not the problem, the thing with this approach, this classic approach about doing science, is that, again, as data doesn't get curated through time, the way that we normally check knowledge or we confirm knowledge is by doing meta-analysis, right? And meta-analysis that you will be interested in a particular question, and you will collect all scientific publications that you found about this hypothesis, and then you will analyze how many of them found a positive effect, how many of them found a negative effect, a neutral effect, and then you will evaluate the effect size, right? Like how big is the effect? And again, this is the best way that we do stuff because finding the original data is difficult. However, we know that now we are increasingly dominated by a practice of science that is totally data-driven. So this is data that sometimes is collected with no specific purposes. I mean, within a specific context, but not for testing a particular hypothesis. And it's data that normally is very rich. And what this allows is that you can then inquire the data for testing different hypotheses, right? Under this new paradigm, there is people who have been suggesting and practicing something that's called mega-analysis. So this is opposite to meta-analysis. This mega-analysis is where people collect data from many researchers around the world, and they test a set of hypotheses, right? And what I'm trying to, the key here is that, doing mega-analysis is a better approach. But in order to do this, we have to be able to, have data ready for this kind of analysis. Oops. And of course, the mega-analysis thing is important because we know that theories and hypotheses are constantly evolving. And again, paraphrasing Quintana and Heather's 2016, they say, if more scientists made their data available in such a way that you can find them and reuse it, then you can get data at the same speed that you can think about problems or new hypotheses. And of course, this is an enormous asset for science going forward. I think that we all will appreciate this phrase, unless you are working with synthetic data or simulations. I think, having data available that is ready to inquire is super important to accelerate the pace at what we produce knowledge. And the problem is that sometimes science can be obscure. I say obscure is when, again, it's not because people is bad, it's just because the way that the system is working is sometimes, data is difficult to find, protocols are difficult to replicate, and so on. So just to give you an example from ecology, I'm not expecting that we read this together, but this is a paper that talks about, the importance of data preservation in ecology. And what I really like about this paper is that shows this figure that is quite interesting. So in this figure, in this axis, we have time. And then in the y-axis, we have data itself, the information. And what these people suggest, and based on my observations, I agree with them, is that as time progresses, data start to decay, or data integrity and data quality start to decay. And what are the reasons for this data decay? Well, some details about, the data are lost because they were in an Excel file and, you switch computers. Some data might have been lost because, some storage fail, or, in some time, once that the scientists pass, data also pass, right? So that this is what they call data entropy. So I think that, we should ideally attempt to extend the life cycle of data. Just another example, this is coming from the Lancet, and this is an editorial from the main editor of the Lancet, and the Lancet is the most prestigious medical research journal. Basically, the context of this editorial is that the British government holds an inquiry about, about the credibility of science, in particular in medical research. What is important to mention here is that, this paper is a call of attention, a call to action to improve the fundamental ways in what we practice science. And of course, some of the problems are related to the statistical analysis, but many of the problems are related about how we curate data and how data can be tested, in particularly in the context of medical research. So I guess that I'm trying to prove, well, is this only Cesar's view or the view of few people? So, well, it seems that it's not. And also it's not the view of the external people that is not related to science. Apparently it's also the view of the collectives of scientists. So this is a survey from Nature in 2015. I want to show you is that 52% of the people believe that, yes, we are experiencing a reproducibility crisis. We can see these numbers per field. So in biology, we are quite optimistic. In this case, they are asking what percentage of the publications do you think that are reproducible? In biology, we are in quite a good, we believe that we're doing well in that regard. But something that is important is below here, well, they say, well, what are the reasons because research is not reproducible? And of course, there are reasons that we all know, all the things, but one of them is that at least 40% of the people believe that raw data or access to raw data is an important factor. Almost 80% of people, or scientists, believe that. 40% believe that it's always, and 40% believe that often is a problem. So what is the way forward? Well, to be honest, I don't know, but definitely we must try harder. And again, another example, this is a paper about preclinical cancer research. And in this paper is a call to action from the big pharma companies. Basically, apparently in preclinical cancer research, there's many people who produce data that then is not available, but they report like significant results or important advancements. And then big pharma companies, by reading these papers, they start to do like clinical trials to develop new drugs. And they, in an enormous amount of the time, they are not able to reproduce or access the renal data. So you can imagine that this is a waste of time and money, not to mention that it has a negative impact, in the advancement of new treatments for some of these diseases. So what I'm trying to say here is that data management is an important piece in a bigger puzzle. What also I'm trying to say that academia doesn't incentivize that good data management, and sometimes for that reason can jeopardize science. And some people believe to agree that we are in a science, in a reliability crisis. So the question is what we can do. So some of the things that we can do is to appreciate that your data can be integrated in other people's work, and that other people's data can be integrated in your own work. I think that is a big motivation just to, encourage ourselves to curate data and maintain that available. Also, we should celebrate and recognize good data management practice. I think, of course, positive reinforcement is a good way to generate change. And I think that you should celebrate your own practices and teach others. We'll also should implement and encourage a set of norms about how to use software and how to manage data. And I think that, again, just a celebration for Chloe for creating this group, because, this is just a way that we can, share good stuff, what we are doing good, what we are doing wrong, and how we can improve together. And maybe you shouldn't have the attitude of this guy, but probably you should share his enthusiasm. Another way is that understand that policing is not probably the best strategy. And this is a paper that talks about, in general, how bad science is more likely to be prevalent given the current incentive. What I think something that is important is, again, is that it's not about policing or, like saying, oh, this person is not doing good data management. It's more about, celebrating the people who does it and try to imitate them. Of course, some disciplines have done a fair progress in enabling process and system to query and reuse and share data. Something that I really like, I always give an example, is physicists. Physicists are an amazing job in curating, creating, curating, and sharing data. Within natural science, I think people working with genomes and proteomics and transcriptomics, they have incredible tools like NCBI and the Japanese and European equivalents. Something that I noticed when I was helping a friend is that while the database are theirs, sometimes people is a little bit not very careful in how they fill the meta information. For example, they don't report if the sequences that they input have the primers attached or not, what was the host of these sequences, and so on. So in general, the adoption of good data management practice is not fully embraced by the scientific community, but I think that there is an increasing movement to do so. So, what is... All right, so I will give you my view how data management should look like, or is about what. So for me, data management is about how to organize the data, of course. It's about how to curate the data so make it last longer. It's about how to test the data and the procedures that you use to collect the data, and how to manage distributed contributions. And this probably is more relevant for people who is the PI in a lab. And this is basically, okay, you have many students, what system do you have in place to incorporate data to your databases as students come and go, right? And of course, any system that is effective in managing data should feature these 4 elements. And the main aim of featuring this element is that you should aim for data integrity. So this is, keep the integrity of the data as when it was collected, to increase intelligibility. This is make data usable and understandable to others and to yourself in the future. And data should enhance interoperability. So data should be ready to be used not only in a particular software that you use at the time, but should be ready to use in a format that probably is going to be able to be used in the future. So I like to do self-evaluation myself, so I thought to include these kind of questions here. So the first question is, your data ready to use? So what I try to imagine is that, the scientific, your scientific hero, write you an email that's interested in your work and ask you like, okay, I really interested in your work. I would like to test this hypothesis and I would like to use your data to do so. So my question is how many clicks away are you from being ready to send the data? Is your data already sitting in a database, public or private, that you can just share, or you have to do a lot of treatment, data munging before? So will others be able to use your data without friction? I think this is also important. Like, sometimes we have our data in many places, it's backup, but the data sometimes is difficult to understand. So that's important to, like have also the metadata ready so other ones can understand it. The other question is, well, how likely is that your data will be available to be used in the future and for how long, right? And this is something important, especially for us. And again, I don't think that we're bad scientists, but like when you have only 3 years of scholarship plus 6 months and a lot of pressure, sometimes it's difficult to prioritize managing that. But it's something that we should do and try to maximize the time that this data will remain usable and available. And finally, well, what is the entropy of your data? Is your data just leaving your computer? So once that you change computer, it's going to disappear. It's just living in the JCU data in Tropical Hub repository, or is living in NCBI. That's probably more accessible to everyone. So I think these questions, we should remind to ask ourselves these questions every now and then. So now I will give you some of the things that I do. And of course, I'm happy to receive feedback. This is not by any means the best way to do stuff. It's just the way that I currently use, and I will be happy to receive advice. I think something important once that you want to establish processes about data management is to understand how do you generate data. So we can have different data sources. Sometimes we have instrument data. Instrument data is great because normally the instrument will give you data that is already in a digital format. Sometimes the instrument will give you also the metadata. So it's fantastic. I myself work a lot on the field doing observations. So I have to collect my own metadata. So I have to collect the time, the days when I went to the field, and so on. So, however, sometimes I use instruments as well. In this case, I use these loggers. So this is a logger that measures temperature and oxygen in the water. And these loggers are great. Something that is not so great is that the file system that this logger uses is proprietary. So that means that you get a file that you cannot open with Excel or a text editor. And at the same time, of course, as this is proprietary software, proprietary file system, you have a proprietary software. So what do I do when I go to the field? I collect, the meta information about the sensor, what time I install it, what time I retrieve it, was the battery low and high, and of course, this is indispensable information that I should consider when analyzing my data. The next thing that I do is that this is I don't know if you can see my cursor, but the .hovo format is the proprietary file system that they use. So the next step, once I collect this, is that I convert all files to CSV, that is a friendly file system. And it's going to be able to last longer. And that's it. I'm also working with videos and images. I decided to employ the NASA approach. So NASA they collect images from satellites, and they have different processing data levels that they call L0, L1, L2, L3, and L4. So in my case, I go to the field and I collect data about crabs. So my L1, L0, and L1 data products is just the video itself, raw. So it could be, or it could be the video annotated, as is in this case, each square is a crab. So I annotate where the crabs happen. Then, of course, I generate another level of information that is the metadata. Well, where is the name of the file, in which directory is saved, the extension, is the file have an error or not, the size of the file, and so on. What was the purpose of this video, the location, latitude, longitude, and so on. And of course, this information, I think we will appreciate that it's important once that you want to start to analyze it. My L2 data is once I process the data, so I auto-rectify and calibrate the videos and compress the video format. And of course, I do this because it's easy to process the video once that is in a format that is not so heavy. So it makes stuff easy. My L3 product is once that I have the file ready. Well, once I start to extract or generate additional data or variables from the file. In this case, I have the video that is the raw data, but I start to generate, the positions of the crab. In my case, it's important. And of course, then I have L4 data. So these are pictures of crabs. This is a crab. So this is my L5 product. And I'm mentioning this because you can imagine that ideally, I would like to back up all my products from L0 to L5. But sometimes, we don't have the means, we don't have enough space. So what is important, for everyone to recognize, I think, is, okay, which is the minimum level of information that you should back up that can reproduce then all the other levels of information. At the same time, it's important to think about, well, what is the source of truth in your data? In my case, I might have, this picture or this particular, a particular track of a crab, the movement of a crab, but if someone is not happy with that, okay, where is the source of truth? Of course, in my case, the source of truth is the raw video. So we always can go back to the raw video and produce a new pipeline and produce all these data products. So I think we should always think about how data will be used. So what is the best format for analysis? What is the best format for long-term storage? What kind of storage should we use in cloud, local, or drive? What is the procedure to include more data? And I think this is super important. And how many copies of data should we create? Of course, this is something that I think we maybe don't think hard enough sometimes. And well, we have to decide about the future of our data. Many of us see our thesis and our data as our babies. So if we do, we should take care of them as they were our babies. We care about, what will happen to them in the future. So some of the first thing that you should do is assign ownership. So is this data going to belong to you only, or belong to your collaborators and advisors? Also, which people and funding bodies were involved in collecting data? And of course, this will make you reflect on what are the ethical and moral obligations of you of preserving data into the future. Decide about data license. You can impose a private license or an open license. And decide who, why, and for how long data will be curated. I think this is important. And of course, this is a decision that often should be in the hands of the PI in any research group, but I think it's important we also reflect about this. And who, what is, and where is the source of truth? Again, there are many examples, and I didn't want to put so many examples to make it boring, but there's many examples where people have been trying to collect data from scientific publications, and what they found is that each author in a publication have a different file. And when they are inquired, okay, which is the file that you use for the analysis, sometimes they don't remember or they don't know. I think it's important to decide, okay, which is going to be the source of truth. And of course, you can do all this by yourself, or you can, pass your data to an archive or a reputable, secure organization, again, like NCBI and so on. Something that I would like to mention is that, as cooks, when they do their job preparing an amazing dish, they care about each process. They care about, testing the different ingredients. And I think that, we are similar to them in the sense that, we care about the whole meal, the whole product that we do, that is knowledge. So we should care about, each particular ingredient. And I'm sure that we care. So what I want to mention in the next slide is an increasing trend to do data testing before you do any analysis at all. So let's imagine in my case, I have a file in R, a CSV file that have, where the crabs occur in a particular area. And its files will look like, okay, I have an ID name, is a character, then I have the position where the crabs occur, and then they have the taxa, and maybe many more variables, right? So you can create a test, and the whole aim of this test is to make sure that there is no mistakes in the data, there is no a typo or errors that can be propagated in the analysis. So what you can do is to define checks. So let's define a check within this function data. So you can say, well, for each column in all the columns, check the data type and also check the minimum and maximum values and maybe how many NA we have, right? Of course, if you are doing, if you are doing a checking, we have to define some expected numbers. So in my case, I can say that the expected values for my data types is character. So I expect this column to be a character and these ones to be numeric. And then for the values, I can expect that the first column, I don't care because it's characters, but the second column, you know, I'm collecting data just around Townsville. So I know that the latitude should be between -20 and -18 and so on. So once that you have your expected values and your check, you can compare, okay, is my data similar to expected values? Yes. Okay, well, the test passed. It's not similar to expected values? Well, the test failed. And that's raising a flag that then you can go to your data and say, okay, what was the problem? And of course, once you have this kind of checks, you just like running in your data. And just, again, like you are aiming to all the tests to pass. Of course, something if we are talking about coding or even data, it's important to use descriptive names. You can see that now I have the same function, but instead of giving descriptive names, I just did like, you know, short names E1, E2, C1, C2, T1, T2. So this is all good, right? But the thing is that you really want to, you know, like increase reproducibility and, you know, testing data and understanding and knowledge, you know, you should use, you know, descriptive names, or if you use obscure names, you have to document well, you know, and we all know that this is something that we all consult every time that we do an analysis or we need help. You know, in any software, something that is critical is documentation, right? Where you define, you know, what each particular function means and does. Of course, we also have to document your analysis and code. I think something that we don't do frequently and trying to do, encourage myself to do, is include vignettes. And this is, you know, explain the naming convention, the functions and variables that you define. So this is from one of the software that I have been working on. So I define which this particular script does. So this script defines constants that are used by other modules. And then I define, you know, which value, what it is and what is the purpose. So in this case, dimensions, store the quadrant dimension, in space, color set, this is a Boolean, so this is true or false, and so on. I think this is something that would not only improve, you know, I mean, it will improve your own, you know, workflow, right? Because once that you start to do this, you don't have to rely on your memory to go back and reanalyze stuff. Of course, I think organize our code. We always talk about this. You can use tools like GitHub. I think most people is increasingly doing this. Something that is important with data is describe, you know, the structure of your project. So this is a particular project I do where I do some machine learning. So some section that I include is, okay, what is the structure of my project? Where is the training data? This is the validation set, the test set, and how it's organized. And again, this is important because if you go back to your project or to your data many years after, you can consult this kind of documents and it will make easy to remember. Something that will also, I think I try to practice a lot, is to do just short script for a specific task. So I had seen, I do it myself sometimes, you know, I have some R scripts that might be 300 lines long. That's just like too much. You know, if someone else wants to understand your script, they are going to get lost unless it's, you know, perfectly well documented. So what I try to do is that I try to compartmentalize your code. So for example, in this case, this is just a script that is 32 lines, only 32 lines. And this script is just a function that converts an image from a shape file to a raster. So normally what I used to do is I have this function in every script that I need to do this thing. I will just run the function with the script. What I decide to do is now convert it into a function, save it in its own script, and then you just call that script and that's all. So instead of having additional 32 lines in any other script, you only have one additional line. Of course, creating metadata for the data for the course and procedures is also important. Effectively tracking different versions of codes and data also important. And also for some people working with sensible data, you have to think about the ethics, right? You are working with humans, you have to be careful about what data can you make public or available to others. So in conclusion, I think data management is an essential aspect of our research endeavor. I think it's paramount that us, the current generation, and the next generation of scientists embrace good data management practice. And this is important because sometimes people who is already established or is a little bit old, they are more resistant to embrace this kind of practices. I think data management should be part of our professional formation, and it should be thought as part of the research curriculum. Again, we should celebrate, people who do good data management. We should embrace practices that maintain data integrity. So the 3 I's: data integrity, increase data intelligibility, and expands data interoperability. So that's all that I have. I'm happy to receive any feedback in any aspect of the talk. It was clear or not, any aspect of my data management workflow, or anything. Thank you.
Awesome. That was great. Thanks, Cesar.
Yeah, thank you, Cesar. Can I just pay you to come just organize my shit? I'm too lazy, but mine's so bad.
It does seem like there is a big investment. Do you see like a saving, like investing all that time into setting up this curation system or whatever? Do you actually get that back in the end, do you think? Like from having, like not wasting time later on or something?
Yeah, I think that's something that we should do, like definitely setting up a system and a pipeline to curate that. And that's because I'm so jealous of, people working with genetics or physicists, because they have already the system in place, right? It's just a matter of training people and teaching people how to use it. But they have this amazing system. For ecology, and I don't know the ecologists in the room, if they know about anything particular database. I know that there is a database for movement, but unfortunately doesn't accept data that doesn't have latitude and longitude. So in my case, my crabs, they move inside a quadrat. So, it's difficult to assign a latitude and longitude. So I cannot push my data into this database. But yeah.
Yeah, that's true. I mean, I'm a geneticist and mine is so unorganized, but I mean, I work on a non-model organism and all that shit. And I'm just hopeless. Lorenzo, I know you just said in the chat that you need the recording. Don't worry, it has been recorded. So yeah.
Yeah, I think something
really good.
Something important is that, and many of these ideas are not my ideas, right? As you see, for the reference are taken from everyone else. But I think something that we should do as the current generation of scientists and the people who will train the next one potentially is to think about ways to encourage, good data management practice. Like try to correct some of those incentives that, I'm not telling you that are good or bad, but sometimes they don't incentivize some aspects of our practice that maybe they should. So yeah, I think that we have to be creative in that way.
I feel like I should write into my like my default R markdown, like just a big like in bold at the top. Do your data management before you start. Because I've literally just had to come back to a chapter. I haven't done any like result analysis for a while before it's done, and I had to redo something. And normally I'm quite good, like I keep my old versions of stuff, so it'd be like 1, 2, 3, 4, whatever. And suddenly I just realized the last 4 versions were like 4, but they're all saved in different places, so they're all different versions. And I'm like, oh my god, which is the most up to date? And I'm like, I've got no idea. Oh yeah, I feel
I think
sorry
that's
for
a
anyone
very
who
common
ever.
problem, eh?
Yeah.
Yeah, I think
The
also in
multiple
genetics,
Excel spreadsheets.
even if we have those databases, it's difficult to use the data because they put the raw data, and it just makes it impossible to use. So I understand that for pictures it might be better to get the super raw data, but I'm not quite sure in genetics if it's something that will make your work useful.
Yeah, for me, like at least in my opinion, the gold standard is if you have a document that takes your code, with words like almost like Microsoft Word, and takes your code throughout and explains each step of the analysis from the raw data processing it to the end. If you can simplify your analysis to that, that's for me that's the best. But a lot of cases, there's some analyses that can't be that simple.
Yeah, I always try to make a good like R markdown walkthrough, but I just think I just end up with too many files and different versions. I would just feel so bad. I thought about it the other day because my lab books got destroyed in the flood. So I've got all like my raw data and everything like on my computer and like methods and stuff, but none of it's organized all together. And I'm like, shit, if I got hit by a bus and couldn't finish my PhD, if someone else had to take over, they wouldn't be able to do it either. Because there's no like, because that was my like order of everything. I'm like, shit. But hey ho, lessons to learn for next time.
Yeah, Sandra says in the chat that she includes the date in her files. That helps keeping track of wishes.
Yeah, Roger does that too, so maybe that's why you do it here. I always find it really easy to find his stuff because it's always got the date on it. Right. I really should do that. It's quite simple. So